So for the next question, we have 6 gram of hydrogen gas at a temperature of 273 Kelvin was isothermally expanded to 5 times of its initial value and then isochorically heated so that the pressure in the final state becomes equal to that in the initial state. So for that problem, if we draw a P versus V graph, let's say this is state number 1 and the gas is expanded 5 times of its initial value. As from 1 to 2, the process is isothermal. Here temperature along this line will be constant. That means here T1 will be T2. And then let's get back to the question. Then isochorically, that means keeping volume constant, heated so that the pressure in the final state becomes equal to the pressure in the initial state. So let's get back. That means the pressure in 1 will be equal to pressure in 3. And as the process is isochorical, that means the volume will be kept constant. The graph from point 2 to point 3 will be a perpendicular line over volume exists, because in this case volume is kept constant. So from 2 to 3. So here, according to the question, the pressure in state 1, that means in this initial state, is equal to pressure in the final state. So now in the isothermal process here, that means from 1 to 2, where the process is isothermal, that means temperature is kept constant, according to the question, as it is expanded 5 times of the initial value, V2 is 5 into V1, and we all know in isothermal process change in internal energy is 0. That means in isothermal process the total heat change is only used up in doing external work. So will be dW here, and by formula we all know nRT ln V2 by V1. So we have to now find out number of moles. We know what is R. We have to find out temperature. Look, temperature here is given, and the amount of hydrogen gas was 5 grams, so 6 grams, sorry. 6 by 2 into 8.316 into temperature 273 Kelvin ln, it will be 5, that amount of joule. So we will have an amount here, and it will come around 10942.5 joule approximately. So this is the amount of exchanged heat in the isothermal process, that means while going from point 1 to point 2. Now here, keeping the volume constant, here as in isochoric process we all know work done is 0. That means total supplied heat will be used up in changing internal energy, and which is actually NCV dt. So here dt is, look, it starts from 2 and ends at 3. That means dt will be T3 minus T2, and we already know T2 is T1 because 1 to 2 was isothermal process, and that was 273 Kelvin. So we can write this as T3 minus T1. So now we have to find out T3. So for 1 and 3 we can write, because here P is constant, we can write V1 by T1 is equal to V3 by T3, and we already know that V3 is actually equal to V2 because the process 2,3 is isochoric, so volume is kept constant. So we can write V2 by T3, or we also know V2 is 5 times of V1, so these two will go out, and T1 is already given 273 Kelvin. So using this we can find the temperature at stage 3 will be 1365 Kelvin. So we have found T3, then we can use this equation to find the exchanged heat or heat change while going from 2 to 3. That will be N is 3. As hydrogen is a diatomic gas, we all know for diatomic gas gamma is 1.41, and we all know Cv is R by gamma minus 1. So let's plug in. R is 8.316 by 1.41 minus 1, and T3 just came out to be 1365 Kelvin, and T1 was 273 Kelvin. So this amount of heat was actually exchanged while going from while going from point 2 to point 3 in a isochoric process. So here the answer comes out to be 67977 joule. So total heat exchanged is dq1 plus dq. We get that is our answer.